Welcome to MineTwin's YouTube channel, where cutting-edge simulation meets daily decision making. I'm Jacobin, and in today's how-to video we're going to show you how to use the automatic sensitivity analysis to determine your optimum fleet sizes. For this experiment we want to test what is the impact on the production and development outcomes of our mine if we change the number of trucks and excavators. If you want to compare vastly different scenarios where you, for example, change the mine layout, different rules, or anything other than the number of equipment pieces, you'll have to create separate scenarios for these. And MineTwin has a special analysis mode called scenario comparison, where you can then compare these scenarios. If you are interested in this functionality, please look at the link in the description below or click on the link that appears above the screen. Now, although we'll be showing this functionality inside MineTwin OpenPit, it is also available in MineTwin Underground and works in exactly the same way. So for today's video, we're going to use the demo scenario that you can find inside the standard library inside MineTwin. So if you hit on the welcome page, standard library, and the demo scenario for OpenPit, you'll see that it's a pretty basic scenario that opens. And the first thing we're going to do is we are just going to simulate it and see what the outcome is. So once the model is finished running, we can see that we managed to achieve our production as well as our development targets. The mining plan was 1.5 million tons for production and 3 million tons for development. If we have a look at our truck statistics, we can see that we had kind of low utilization. We've got some here in the 60s, here close to 80%. And we can look at the statistics, the stack charts here as well, and look at our excavators, also very low utilization. So we can clearly see that we've got more than enough equipment pieces to meet our target. If we have a look at the blocks, we can see from our production blocks that there's about 300,000 remaining that we can use, and about another 1 million tons of development blocks that we can mine. So what we're going to do now is we're going to go back to the scenario editor. We make sure that our scheduling mode is by target, and then if we go to our target plan, we're going to increase our target for the production to 1.8 and for our development up to 4 million to make sure that we're putting as high a target as possible for the model. Now, one thing that you might have noticed when we went to the trucks is that the trucks are pre-assigned to specific locations inside the model. So we've got a number of trucks assigned to the grey area, lime area, violet area, etc. So what we're going to do is we're going to take our trucks and we're going to remove their assignments to the specific locations. And we can do that by clicking on the truck and deselecting the mining area, so it means that it can work at any specific mining area. And if we've got this selected, we're going to right click on that cell and we're going to say apply to all rows, and it will apply that specific value to all the entries below it, thus removing the mining area assignment to all of our trucks. And we're going to do exactly the same thing with our excavators. And the reason for this is that we want our scheduling algorithm to decide where to allocate the pieces of equipment, so that when we do our sensitivity and we add more pieces of equipment or we remove pieces of equipment, that the resources will still be shared as per the scheduling's calculation. Okay, so now that we've removed all the mining areas, we're just going to simulate it again to make sure that the changes we've made now gets applied correctly. Now that the model is finished running, we can see that we are still achieving our plan of now 1.8 and slightly even above our development plan of 4 million tons. And if we go to our trucks, we'll see that our utilization is now a lot higher, but we also have a lot of lost time because there's just too many trucks at any given point. So if we have a look at the full screen view of the statistics, we can see that there's a significant portion that is waiting for loading. So we've got too many trucks, so we're sending them to their location, so they end up waiting to be loaded by the excavators. If we have a look at our excavators, nothing really changed here. The utilization is still very, very low. So now that we know that we've got the highest target possible and we've got the flexibility in our pieces of equipment and that we've got way too much equipment, we're going to go to the fleet sizing analysis feature. So OpenPit also has an advanced fleet sizing parameter that you can use if needed. So we're going to the fleet sizing and we're going to the settings, and now we're going to say we want to change our number of trucks all the way from 30 to 45 trucks, and our excavators all the way from 5 to 20 trucks. And depending on the level of randomness inside your model, you might want to run multiple replications. So for this one, if we're just going to run 5 replications of each, the replications is there to make sure that we get a statistically valid result. Okay, so now I can hit the run button. So depending on your computer's hardware, a certain number of parallel executions will run, and that depends on the number of CPUs or the RAM that you've got available. Now, typically when running these big scenarios, I opt for a standalone computer or even rent a server. Typically on servers, you can get a lot more processing power and memory that you can use. And the added benefit is it doesn't lock down your local computer, making it hard to do other tasks. So for this specific example, I've already set up this test on our remote server. So if I navigate to the remote server, you'll see that it's completed all the scenarios that I've asked for it. So on the left-hand side, we can see the number of trucks ranging from 30 to 45, and at the bottom we can see the number of excavators going from 5 to 20. The color ranges here show how well we achieved the target. Blue is above target. So we can see that as soon as we get to like 33 trucks and above, we will reach our target almost regardless of the number of excavators that we've got. And the number of excavators here from around 15, we start running into problems. We can also make this full screen, and so you can see some of the numbers and the percentages being applied to those different blocks. So basically what it's showing here is that if you get to like 33 trucks and about 16 excavators, you'll be able to achieve your target more often than not. And anything below that, there's a risk of not achieving your target. So now that we've completed this analysis, the next step is what do you do with the results? How can you get it out? Now, MineTwin offers two good alternatives for getting data out of MineTwin. The first one is on any table that you see. You are able to right click and then you can choose view in Excel. If you don't have Excel available, you can also just copy all and then paste it in any location that you like. So if I'm going to view this in Excel, it basically just opens up the table inside your Excel and you can save it anywhere for post analysis. So here we can see we've got all the details from that specific table. If you are looking for more detailed information, you can also just use the export results to Excel functionality, which allows you to get a lot more detail from the different scenarios inside Excel for post analysis. And as you can see, as we've got the results inside Excel, it's easy to navigate through and get all the detailed requirements that we want. Thank you so much for watching. If you are curious and want to learn to know more, please contact us, use the links in the description, or download your free copy of MineTwin today. Until next time, thank you.